Thanks to all for coming. Also, thank you to the guys in Santa Monica, Pittsburgh, and Kirkland for video conferencing in. I would like to introduce Paul Bakaus, who is going to talk about his pure JavaScript-based web game engine.
Thank you. So here we go. So yes, my name is Paul Bakaus. Just for a quick introduction, I'm the guy who has started jQuery for anyone who has played with jQuery and jQuery before. And therefore, I'm quite experienced in all kinds of user interface. And this led me to one of my really most sophisticated projects yet, which is gaming on the web. And today I will be talking about how to build a game engine and what I learned from how I did it. So thanks for joining. So actually, first question, why build a game engine for the web, right? What is the purpose? First of all, let me show you how the game development industry right now looks like. If you look at browser game development versus console games and PC games, there's really a big difference. But on the end, if you're a developer, you have the same questions to answer first. So you have questions such as, what kind of genre are you building? What kind of game is it being? Do you need single player or multiplayer? What platforms are you targeting? What tools do I need for development? And how does this game actually scale if it's multiplayer, for instance? So the basic questions are always the same. However, if you look at the classical game industry, you have a lot of convenience already available. There's a lot of middleware, countless tools and frameworks to choose from for any kinds of things, for scripting, for 3D rendering, for anything. So in that picture here, you see just some quick names you probably might have read somewhere. Quake Engine, Unreal Engine, Unity, all those engines are already available. And no game developer in the industry would start over from scratch. It's just not happening because that would require many, many years of work. So that kind of also, those frameworks are really very easy to extend with other genres and with other combinations and modules. So most of the companies license a framework and then build up on it, which is fine. However, if you look at the browser game industry, it's really completely different. So browser games are often grown from hobby projects, and development is often copied from app dev paradigms instead of actual games. There's no real technical standard, so it's not either C or Java. It's really the open web stack or Flash or Unity. There's all kinds of techniques. There's a lot, and seriously a lot, of legacy code flowing around, and I'm going to talk about why in a minute. So secondly, browser games tend to have a long lifespan, and that's the issue with legacy code, right? And they tend to have a much longer lifespan than a normal game. If you build a console game and release it, might be that the sales are holding on for about a year. If you're building a browser game like Farmville or any of those competitors, really that game is being there for many, many years to come. And that's the issue, right? You have to maintain a lot of old code. So we're talking to many game publishers, and they mentioned it's a huge pain because they have to maintain code that is 10 years old sometimes. So really, it's a different world. And that code isn't using a framework, so it's really custom. It's not interchangeable, which is really tough. If you're looking at the frameworks we can use in the web, right? Anything that displays in the browser, you only have a very limited choice. So there's very few good commercial Flash frameworks that you can use. There's no commercial JavaScript frameworks that I know of. And there's a couple tiny projects if you look at JavaScript. Most of them are concepts, and most of them are dead, unfortunately. So if there was a framework right now, I would probably be using it and build my own games, but there wasn't. So the logical consequence really for game publisher is everything is being developed in-house, and you're gonna have the in-house technical knowledge, and you need to build up on it. You have to build in-house tools, and you have to build your in-house frameworks. But why are there no frameworks? What's the reasoning behind that? First of all, the browser game industry is really young if you compare it to the classical game industry. The classical game industry has an advantage of about 25 years, which is not to be underestimated. So really, we're just starting. We're just in our childhood right now. And then also, only very recently, we got powerful enough hardware to back up games. So to run lots of crazy JavaScript, new advanced technologies, HTML5, you probably heard the buzzword already, CSS3, all kinds of things popping up, and many companies are behind those efforts right now. And it's really changing. And finally, we have the engines like V8 in Chrome and Nitro in Safari that can power games. For instance, in our case, we have been building prototypes for the last 5 years, and every half a year we found out that the time is not ready yet. So we tried again in another half a year, and once again. And finally, last year we discovered it's time to release something. So this is why I gained all this experience. Additionally, and this is also very important, there's lots of knowledge needed to build sophisticated games, and many started it as a hobby. So all the game companies you're seeing, Farmville, I'm not so sure about Farmville, but all the big strategy-based browser games are really hobby-based, and they're grown from a hobby. And usually it was a web developer by himself who started this, and then it just exploded very quickly. But there's an issue with that, because actual web devs are seldom good game devs, and vice versa. So we have a problem here. Really, it's very, very hard to find someone who is experienced with games and can build user interfaces, can build game code, can do mathematics, and combine it with the web world. Write HTML, write JavaScript, write CSS. It's a tough job, really. And there's very few around us that know both worlds. So reality without frameworks really looks like this. Countless iterations of code. You write everything from scratch. This is really how it is. We've been going to many companies, and they all share the frustration. So, but I say, sweet, right? Sweet, because we have no competition right now. There's high demand. And you at Google probably know about this, because you're trying to get into gaming big time. So let's rock. So let's take a look at the open web stack and how to choose the right technologies, right? As I mentioned already, we have a huge mess of technologies right now, and we have to care and pick wisely. So if you look at Flash, for instance, we looked at Flash and we investigated if it would be the right choice. Really from a far ahead approach. So Flash has obviously the disadvantage that it works almost everywhere, but not on any of the smartphones. And if you're building a desktop engine, that might be fine, right? However, if you're trying to run on smartphones, Android, iPhone, whatever, right, you're targeting, Flash is not your choice. And well, I mean, you could say we've been seeing Flash in Android, in the newest version of Android, but it's not there yet, and it's not completely there yet for the customers. So I think personally it will still take some time until we really see Flash for the mainstream audience. So when we analyzed Flash, we saw the pros, obviously. It comes with a pretty good IDE. So the Flash IDE is very powerful, and this is why many developers love to use Flash. It's installed on most desktops. Multimedia handling is very easy. Platform-independent rendering, obviously. And we really have some good communication protocols as well. So it's a lot easier to use binary streams to communicate with the server than it is in HTML. Well, in HTML it's not possible, actually. So we still have to find some patterns. Contra. Third-party JavaScript APIs and widgets cannot be embedded into Flash, because Flash doesn't have an HTML rendering engine. So there's no way to actually, it's really a black box. There's no way to really integrate mesh apps and widgets and the open web in general. So that is one big hole. Scalable viewports are very difficult to do, and I have a nice example later on. And distributed development is also very painful. It has been getting a bit better with Flex, I think. but still, you are compiling your code, and it's very difficult to maintain, in my opinion. And obviously, no relevancy in the smartphone market. So what we choose, obviously, is the open web stack. We choose to develop plugin-less. And let me show you what I can say about that, right? So Pro, it works on every mobile device and on every desktop. It adopts many Flash features, and recently adopted many Flash features. For instance, video, audio, sockets. There's very easy integration available for widgets. Most of the time you can use services like YQL, Google Maps, embed all this automatically into your code. There are tutorials floating around everywhere, so you can build a really nice social game with it. It is, in fact, closer to hardware. So Flash has been getting hardware accelerated for some time, but now we're seeing CSS3 being hardware accelerated on mobile devices, which is quite some big leap forward. So in the future, the browsers will be a lot closer to the hardware than Flash can ever be, because the development cycle is a lot closer. And Flash-like animations are finally possible. For instance, using CSS animations and CSS transforms, we really have some powerful tools here. And yeah, engines are already mentioned. So what's bad about HTML and CSS and JavaScript? Obviously, there's no real front-end IDE. Some of you might argue that Dreamweaver is a real front-end IDE. I won't say any more about that. But development of great games is very painful using those techniques. Obviously, because you have to care about cross-browser. You have very few JavaScript experts in the industry, still, even in 2010, and especially with focus on gaming. And those are really the problems that we're facing. And obviously, you have to combine all kinds of technologies. You're not writing in one language. You're writing in CSS, HTML, JavaScript. And so it's really a mix. So our pick was still HTML, vanilla HTML for rendering, JavaScript for scripting on the client and on the server, and Canvas, but not for rendering, and I show you why in a bit, but as a tool. So, and this then, for having cross-browser support, we're using Canvas from Google to bring Canvas to a cross-platform, and CSS transforms we're using as well, which is now in Firefox and most WebKit-based browsers. And we're doing it cross-platform using Transforming, which is a plugin I wrote recently that emulates CSS transforms in Internet Explorer. So, but think about cross-browser, right? If your engine is really platform-specific, if you're building an engine for Android, right, then there's really no point in doing cross-browser, because you're wanting to do Android games with it. So example, mobile WebKit or mobile whatever, mobile Gecko. And there's pro and cons to that. Obviously, you have a limited audience then, and you can't push it to other platforms. However, there's an extreme development speed up. So you really have to think if you want to do that, or if you want to do a real cross-browser effort, because it's going to take you 3 times the amount of work. Just one thing to think about, right? Also, and that might help you as well, don't worry about today. Worry about the future. So you have to pick the technologies from the future, because if you're building a game engine right now and then building games from it, chances are that you will not be ready by 2012, right? 2011. So really building an engine and then building a great game of it will take some time. So think about the release time. What kind of technologies can you expect once you release your game? And that's really a key effort that you have to think about. And of course, what we're also using is jQuery and jQuery. jQuery mainly because it's a library focused on certain tasks. Therefore, it doesn't get in our way. So it would be unwise to choose a really big web application framework in JavaScript like Dojo, because that would really limit us in some extent, for example, or EXTJS as well. So we cannot have a framework that restricts us, because gaming is so different. And jQuery comes with great event support as well. We're using a lot of event-driven code for the games, and you'll see later why we need this. Why jQuery? jQuery, really, we can't use any of the widgets because we're not building a web application. But jQuery UI comes with some great core helpers for mouse interaction, for instance. So that's why we're using from jQuery UI. And right, so let's continue. We now know what kind of stack we're using, right? So let's think about architecture and API design. So what do you want to keep in mind when building for the web? First of all, impossibilities. If you think about games you want to build, genres that can't be implemented now, but pretty soon, are, for instance, casual 3D games, simple shooters, using WebGL. So WebGL, I don't know how many of you have tried it out already, but WebGL is a pretty fresh new standard that brings 3D to the browser using OpenGL. It's kind of a direct, almost direct ported interface from OpenGL. That also means that you do not have any advanced shaders or anything you have in a greater framework. So it will still take some time until you will see really nice 3D games using WebGL. And genres that can't be implemented now, and for many years to come, in my opinion, are next-gen 3D games. So if you want to see a new Final Fantasy on WebGL, it will take some time. So WebGL is simply not as advanced as I want it to be. So we decided to do something different. We decided to focus on 2D and 2.5D. So 2.5D is isometric projection, and 2D obviously allows you to build puzzles, adventure games, board games, card games, platformers, jump and runs, all kinds of 2D games. And 2.5D allows you to build any kind of 3D game. Well, I wouldn't build shooters, I guess, and I wouldn't build a racing game. But then, on the other hand, it's really great for strategy games. It's really great for RPGs, turn-based strategy, real-time strategy, and simulation, SimCity, for instance. So there's really a lot of games you can handle already using those two projections. So we choose really what we wanted to do, and we hired a designer and figured out what kind of game do we really want to do. And we choose this kind of game. So this is some prototype mashups, prototype screenshots that looks like a game we wanted to build. So you see isometric projection. This is the actual world, and you see the interior of the homes of people. So it would be a kind of social experience here. That's what we're imagining for prototype, right? So this is the kind of game we wanted to build, and that was our vision. And then we figured out what we need for that, right? So if you think about what are the requirements for that game, you need stuff like free mouse panning, infinite real-time worlds. So I want to have a connected world, animated characters, chat bubbles, collision detection, pathfinding, walking into houses, mashups, sound effects, scalable viewports, and the list really is longer than that. There's a lot of stuff you have to care about. So most of you might say, okay, this is awesome, but it just sounds like the Duke, right? Really, but yes, it sounds like the Duke, and it will take forever if you try to develop a classic game engine. But we're not trying to do that. We're trying to build an engine that is focused on the web. So we're really optimizing for the web. And I will show you what that means. So let's actually get over to some code. Let's show you some of the techniques that we found out works for games. So first of all, rendering. Rendering is the most important topic of all. How do you render 2,000 objects onto a map, right? 2,000 houses or tiles or whatever. So how do you do that? How do you do that so that it is speedy, right? So in our tests, in our experiments, we're trying to render 2,000 elements in less than 50 milliseconds, which is quite insane. But that's what we wanted to achieve. And the most obvious idea was to use Canvas. So yes, we'll obviously use Canvas. And we tried that. We tried to use Canvas and render. But the sad experience with Canvas really lead us to realize that Canvas is a lot slower than HTML. So why is that? The Canvas image API is pretty inefficient because you first need to actually have a DOM representation of the image. So you have to first load it in JavaScript, have it load until the end, and then render it to the canvas. So there's a step in between, and this makes rendering very inefficient and will take a long time. if you're playing with many graphics. So if you're working with a lot of graphics, Canvas is not your choice right now. If you want to do something that really is abstract, right, and doesn't use a lot of graphics, you might want to do Canvas. But in our case, it was way slower. So what can you do? What can you do with HTML? So first of all, block rendering. What does block rendering mean? Block rendering means directly replace inner HTML with a huge string instead of multiple DOM append actions. So this gives you a huge performance boost because that string of HTML you're constructing is directly parsed by the HTML engine. So the HTML engine is parsing the content and displaying it, which is a lot faster than going through the DOM and appending elements there. So it's really fast, and reflow and repaint, two things the browser is doing to display content, are only occurring once. That's another big advantage. So in a DOM operation, you're pending, and you're doing a next step, and you're pending, and all the time it needs to redraw first until it goes to the next step in most cases. So, but then on the other hand, we have a huge disadvantage here. The huge disadvantage is that you cannot reference individual nodes anymore. So if, for instance, you're having 500 houses and you want to render them to a map, right? You have 500 houses, and then you want to pick out one of them and actually animate it, right? Or display something and do a click action on that one. There's no reference anymore to that house. So how can you fix that? We fixed that using lazy node linking, which is really fixing the main disadvantage of the references. And after inner HTML has been set, you simply run a query, in this case using jQuery. So basically what it's doing, it's grabbing everything we built right now, doing a list from it, and most of the browsers have query selectors. So this is really fast. It probably will take a millisecond or something. And now you have a collection of all elements that you just rendered to the map. And since you know the order of how you render it, you can reference back. So really, you just have to care about the order of the rendering, and then you can reference back to the actual elements. So this is how you fix the referencing. So let's move to smart rendering. Smart rendering I call something different. So we have that first step, and it's already pretty fast, and will probably take around 500 milliseconds still to render 2,000 elements. Why is that? So if you look at the code that gets rendered, right, here on the left, on the right, sorry, this would be one of those elements. It has position tags, top tags, all kinds of CSS in there, margins, background images. So this is one block, and you gotta have to do that 2,000 times, right? So you have a huge string constructed. And but this is really how most people are doing it right now. So they're building this and style them via JavaScript directly on the style tag, render them through inner HTML, and that's still kind of slow. So we really want more. So what did we do? We realized that we kind of forgot how to build websites. So the web method really is, don't ignore the layout layers. So especially not external CSS. So one thing you could do is actually keep the style tag very minified, only use some class names to actually hook them up to CSS classes, which then define background images and all those things. There's still, it sounds easier than it is because those external style sheets later on need to be rendered by the server in real time. But really, this is fixing so much of your pain because this will render 10 times faster. So I don't know why, but it seems the parser is really taking much longer time in constructing that huge string and deparsing it instead of external style sheets. So that would be one method. Also, what I also mentioned, everything then is rendered through the CSS rule, right? Including background, margin, padding, etc. So that was rendering. How about delegation? So how do you actually make sure that someone can click on a house? So first of all, event delegation. How many of you have heard about event delegation already? Some hands? Okay, few. Event delegation is a technique to forward events to implicit listeners. So in web development, that usually means the following. Bind an event to the root node so to the body tag, for instance, except for the actual child element. For instance, if you want to click on a link tag, on an A tag, and you want to bind a click event to it, you would usually bind it to the A tag directly, but in this case, you bind it to the root node and then filter out in the call what kind of node you clicked on. So this is event delegation, which means if you actually replace that link later on and bring another one in again, it still works because it's not really bound on the actual node, it's bound on the top node and then references back. So the the processing efforts, and that's also very interesting, really moves from when the event happens, to the event happens. So usually it takes a long time to initialize all kinds of events, but what this means is you only initialize an event once, and then when the event happens, the processing is used to calculate, is this what I want to click on? So this really helps on speeding up your applications. So for us, that means we realized we only really need 3 events, and that are bound on our prototypes. So the one event is mouse move, which handles positioning, position detection, and dragging. The other event is mouse down, which also handles drag start and clicking. And then there's mouse up, which also handles drag stop and clicking as well. So those are the kind of events that we're using, and we're only binding them once to the document. And so, yeah, cool, we have events bound, and we can click on houses now, in theory. But what we also realized, if you see that house here right now, this is a PNG that has some transparency in it. And obviously all div elements are rectangular. So if the user actually clicks on the left top corner, it will actually still trigger the click on that house. But he didn't click on that house graphically. So that's not what we wanted. So what we figured out, this kind of sucks. And we really wanted to match the user's intent. So you really need to be creative about that. We choose not to use canvas, but what we did now, we built click-through maps. So what I mean using by click-through maps means I build up a pixel map for each of those PNGs and objects that tell us where the transparent pixels are. And then in the event delegation, I'm filtering those transparent pixels out. So that means if you click on a house and you click on a transparent pixel, it will not execute that click. And this fixes our issue, which is really nice. However, building up those pixel maps is a huge pain because it really is not fun if you want to do it manually, right? You have to seriously find out all the pixel positions and get them into a map. So this is really not very effective. So we realized we can have Canvas do it. So what we're doing is Canvas can actually read the pixel data and from images. And then we can check if our pixel is in fact transparent and save this to a false value into a new optimized smaller array. And that array is built up on real time every time the engine is loading for any kinds of graphics. So it just works. And this is really the only code you need for building such a pixel map, which is quite efficient. So that's how you match the click's intent. Different one. This is actually one I haven't talked about yet at any of the conferences and any of the talks. It's brand new and we're still working on it. It's called action surfaces. So this is something you can do in the web, but not anywhere else. Action surfaces really means it's basically a droppable for widgets or other objects. So if you see the TV here, the black interior of the TV will be the action surface. And the action surface is transformed to isometric projection in real time using CSS transforms. And that really is cool because it allows you, for instance, to drag flicker pictures to your action surfaces, and those pictures transform in real time to that isometric perspective. And to really show you how it works, I'm going to show you one quick example in a bit. So this is the code actually that gives you all you need basically in CSS. So you define rules in CSS for isometric angles, and those rules transform your elements to isometry. And to have a proof that this is working, in fact, I made a quick text. Let me quickly switch. So here we go. this is a simple test to show you those classes are actually working. So we got the newest Google logo here. And this is just a div with a background image. And I can basically append those classes, and they rotate to isometric projection. So using those, I could build up a simple cube, for instance. So this really works, and it works quite well. And it's quite speedy. And let's see. If you bring this, okay, I'm not connected, but I'm going to show you later on if you want to. If you bring this to a certain extent, you can build great action surfaces. So this is action surfaces, and I'm going to show you live what it means in a bit. Next topic. This was all about the front end, but let's talk a bit about the back end. I mentioned already we're using JavaScript in the server as well. So why is that? First of all, why do we use JavaScript? JavaScript really, many might think, is really painful enough already, right? If you're working in the back end, you might have that opinion. Now you want me to work with that in the back end as well, and many gave us some very puzzled faces. But seriously, why JavaScript? A single scripting language is so efficient per project. So if you have a single language you're working on and all your developers are working on, it makes developing so efficient because you can share code in the back end and front end and distribute it to any people. And everyone understands what's going on any site, which is huge to me. And well, in my opinion also, JavaScript is awesome. It's just very misinterpreted language. And I really hope people will think about it in a different way in the future. So there's one interesting project we're using. It's called Nojs. It's a JavaScript runtime. So I'm going to really quickly show you what it means. First of all, JavaScript in the browser looks like this, right? Many devs don't want to work on the server because they really are afraid that it will hack down the server. And that's really that fear. I know where it's coming from. It's coming from the browser, because if you look at JavaScript in the browser, the car is JavaScript obviously, and everything around the car is overhead added to it. So in the browser environment, you have the rendering, you have the DOM, everything. You have timers. All that really slows down JavaScript. But if you really look at JavaScript running without all those layers on top, it kind of looks like this, right? This is JavaScript in the backend. JavaScript in the backend is almost as fast as C, which is quite significant. So really there's a huge performance increase if you work in the backend. And also, obviously, you don't have to mess around with cross-browser implications. So you only write using one engine. It really speeds up your coding. So Nojs features, it's Google V8 running on the server in a scripting runtime. It is server and scripting in one kind of process, and it comes with some sugar on top, pretty modules for system, servers, etc. And everything, and that's a key fact, everything is non-blocking in Node. So Node is completely event-driven. File system calls, etc. are non-blocking. I'm going to show you what this means. Then, since it's using V8, it's using ECMAScript 5 as well. So you get some nice sugar on top as well. So for the modules, it's using the CommonJS module system. It's very handy for organizing code, and there's really no way around it in Node.js. Without modules, there's no useful app. Some common modules, sys, file system, HTTP for creating your server, and process. So ECMAScript 5 already gives you some nice features as well. Getter, setters, some array extensions, for each, reduce, filter, and especially JSON support is really nice. So you got JSON stringify, JSON parse. And what's the great innovation about Node anyway? We had Reno before, which was a different interface. But Node really is different. Node is completely event-driven. So for instance, in a normal environment, if you're programming PHP, for instance, you're doing a call to a database, and then you're waiting. In the next line, you're waiting until that call is actually finished, and then progress. So it's in a linear fashion. And it has some advantages because it's easier to understand, easier to grasp. When that line is finished, move on to the next one. Node is completely different. Node is event-driven. So if you do a database query, you need to have your query, and then for everything, you need a callback. So in that callback will be executed once the database is ready. And the next line will be executed immediately. So it's not waiting for your call at all. And if you look at sample code, right, that is running on Node, you have to take this with a grain of salt because those are early versions. But this is just one of the images I found in the World Wide Web that really shows how Node is doing, and it's doing quite fine. So those are the requests. On the y-axis are the requests in 10 seconds, and Node really is at the top, and the concurrency isn't bad as well. So those are the quests per second. So really, Node scales really well, and you don't have to fear about any of those JavaScript mess you have in the browser. But then I also have to tell you that Node.js is pretty new. The API is not frozen yet, and it's really only for adventurous people. But everyone who is building games in the web right now is adventurous already. So the benefits of using it completely make up for the risks. Non-blocking, what does non-blocking really mean? Non-blocking also not only means event-driven code, it also means the server is not threaded, because you cannot thread V8 actually. You do not have multiple processes, and it can serve and handle a lot more requests at a time because it does that, because it eats a lot less memory than, for instance, Apache. So that's really one big advantage. If you look at I/O API, I mentioned already accessing external data is always non-blocking. So you really got that right. It's really hard to stop Node from functioning. So it's very efficient to write event-driven code. So why do we need that for a game? Obviously, if we want to build a game that handles thousands and thousands of players, possibly millions of players, this is really the kind of environment we need. We need event-driven environments. We can't build a game that has many hundreds of thousands of players on one server using PHP. It's just not going to happen. So this is, I explained that already, so just very quickly. So look at the Hello World example in Node.js. I'm not going to go into this much, but this is really a very easy Hello World example. You create your server, and this server is taking in requests, and you execute any kind of code you want and send back the answer. So there's no need for Apache, no need for a second server. It's really just this runtime, and it will do everything you need. So finally, and this is a very strong message that I want to give you, finally get rid of limitations. And what I mean by limitations, get rid of limitations in your head. So, and what I also mean by that is do not copy. If you're looking at the games right now, so first of all, console games are displayed full screen on your TV. This is a no-brainer, right? If you put a console game in your console, it stretches the full screen, always, right? How about the browser games? If you look at browser games, this is one browser game from Germany, Graphically. Very small viewport, right? It's not full screen at all. Second game, you might realize all those games kind of look similar. This is from a different company entirely. It looks the same. Next game, Habbo Hotel. Some of you might know this. Habbo Hotel also has a pretty small viewport. And it's even using Flash. Farmville. Farmville is not stretching to the browser window. Farmville is not an immersive experience at all as well. So think about MMOGs in browsers. Almost all games are limited to a couple thousand players per world instance. And what we really want, we want stretching viewports. We want multiplayer, real multiplayer. Worlds with millions of players. So no technical fragmentation between worlds. And more characters than just 20 in a room on a single viewport. This was really, like, that's what I mean by getting rid of your limitations. Not just because everyone else is doing small viewports, there's really no reason why you have to. And there's really no reason, and I want to prove that there's no reason. And this is really how test that we did looks like. So we're testing sometimes on quad HD resolutions. This is an early prototype of the engine we are writing. And as you can see, it's a 27-inch iMac, which has a pretty significant resolution already, and it's stretching to a complete viewport, and it's really running fast. So let me show you what we have been building. So obviously, this first part was about how you build stuff, but obviously we have built some stuff, and I want to show you. So meet the Aves Engine. The Aves Engine is a professional game engine for the web. It is commercially licensed, and it's cross-platform. So yes, it works on smartphones. It works on Android, hopefully. It works on iPhone and iPad. And it comes with all mentioned features and a lot more. Currently in alpha, so we don't have anything to sell. And I just want to show you because it's quite cool, in my opinion. So demo time. Here we go. So this is our new prototype of the Aves Engine. Let's just turn this big, I guess. Here we go. So this is the prototype that we've built. You might have seen this in one of the earlier slides. It allows you to pen in real time. It's loading new patches. The patch loading kind of works like Google Maps for anyone who works on Google Maps or have worked on Google Maps. So it uses a patch mechanism. All those objects are referencing in real time, so you have those click-through maps going on. As you can see, I can drag around that object, and you can hover it, right? So this is my character, and that character can walk around. You have sprite animations going on here. Pathfinding, I mentioned. So if I want to walk across the street, it's actually walking and following rules. So it allows you to chat as well. And we have been doing quite a lot of performance tests as well. So right now I'm pretty lonely in this world, but let's add some players, right? So we're going to add some 100 players to the map, and you probably can see them walking a bit and chatting. So those are 100 players launching the world right now, and it still scales pretty well because it is using external style sheets for everything, and it's using all those techniques that I explained before. So let's see. Let's actually switch a world instance. So you can move into houses and switch the tile resolution. So we launched a house. As you can see, our character is bigger. We can switch our character as well. So let's see, get some male character going. And those are the surfaces that I was talking about. There's no wireless available right now here. At least I didn't turn it on, but you can get the idea here. So this is a surface that is using CSS transforms, and basically get some surface window, and you can drag those widgets to the surfaces, and they transform and drop, and basically you can drop them anywhere where surface is. So this is really the kind of vision we're having, and our second prototype that we will also show in the next couple of days. Anything I missed? I guess what I can also show you, and really if you want to start building your own game engine, 20% I guess is what you see right now. 80% are the editors, so the admin interfaces, all that. So we also built some quite nice admin interfaces for the Word. You can see them here. So you can you have a tile editor. You can grab some objects, launch a model editor, and then add surfaces to it, drag it around, and it will all synchronize in real time in the Word. So here you go. This is the kind of things we have been building. So I guess we're almost finished. Thank you very much for your attention. There's more at xstores.com and also at our blogs. We are writing a lot about our technical stuff, and we have a lot of demos using CSS transforms and CSS animations. There's a lot of interesting things to check out. Follow me on Twitter if you want to. And also, if you do have any contacts to share with us, we are currently touring California. So if you have any contacts you want to share in the game industry, in the VC industry, contact us. And I'm really hoping to see people building games, not only with our engine, but if you do something your own, that's perfectly fine, and I want to see competition. Thank you very much. Yes, now we have room for questions.
Yes, can you tell me a little bit about what you're doing for audio?
For audio, that's a very good question. So we haven't done audio yet in the prototype. We have been playing around with it, and we're using HTML5 audio. However, it's quite buggy still in most browsers. So I hope it will change in the next couple months. So we're using HTML5 audio, This has some problems. For instance, you cannot run HTML5 audio on iPhone right now. I'm not sure about Android, but it's very hard to start audio in the background in most browsers right now. So yeah, we haven't done it yet. Any other questions?
Sorry. So is this engine kind of geared towards building these type of isometric games, or is it flexible enough to do platformers? Or
it's really flexible. So as I mentioned, this is just a prototype, right? So we really haven't finished the engine yet, and it's just showing one aspect of the engine. But yes, the engine is meant to also allow to build platformers, jump and run games, all kinds of games that you had on that list before. So 2D and 2.5D. And we simply choose isometry because it is a kind of cool prototype, yes. Quite a good experience, and it's really the most difficult experience to build. So this is why we choose it. So any other questions?
How much of a performance difference do you see in different browsers, especially mobile browsers?
There's a huge performance difference. In mobile browsers, you mean?
Mostly, yeah.
So if you look at desktop and mobile browsers, there's a huge difference already. But then there's really many kind of quirks you're realizing when working with multiple smartphones. For instance, we've been working with iPhone and iPad, and we figured out that so our prototype works really flawlessly on iPhone 3GS, and that's really nice. It's also working on 3G, not as fast as 3GS, but it's kind of working. However, we had huge issues to get it running on the iPad, because the iPad itself is almost as fast as it's a bit faster than the 3GS. However, it has a much larger viewport. So the viewport is much larger, which means you need a lot more processing to display full screen. So obviously we could leave it as at the iPhone resolution, but as I mentioned, this is really not what we want to do. So we had to optimize specifically for all kinds of mobile platforms and use techniques. For instance, CSS transforms and CSS animations are hardware accelerated on iPhone, and I think pretty soon on Android as well. I'm not sure yet, but you have to use features that are hardware accelerated. Anyone else? All right, then thanks again, and have a great day.